Hello everyone, this is a quick video in case you like wrestling games. I integrated in the Stable Retro, a fork of Gym Retro, a wrestling game called WWF Wrestlemania, the arcade game. So if you want to have this integration, you can sync Stable Retro. So since, as I wrote, since Gym Retro doesn't accept any new game integration, that's why I created this this repo. So as you may know, I already have Super Mario Bros. 2, Hang On, Punch Out, and now the wrestling game. So in the, I think over 1,000 games Gym Retro didn't have wrestling games for some reason. Then I thought it was interesting to integrate one. And why this one is because this is the one that's kind of a mix between a fighting game and a traditional wrestling game. And I think wrestling games are interesting for AI because unlike fighting games where it's only on one dimension, they move only on one dimension. The fighters move on a plane, so I think it's more interesting to watch, and more interesting to see the strategies of the AI. So I integrated 2 states. For now, it's the very hard state. This is the hardest difficulty with Yokozuna, and also the medium difficulty with Yokozuna. This is the default difficulty one. Also integrated a 2-player state, which I didn't submit yet, commit to GitHub yet. So this is for testing model versus model, the 2-player one, and because I intend to do a script later on for some sort of competition between 2 models over the network. I'll talk about this in another video. But for now, I'll talk a bit about how I integrated. This is not a tutorial on how to integrate the game. I already did this in a previous video. I put the link down below. But I'll still show like what I did. It's pretty simple. So basically, there's only 3 values needed to read from RAM, to be read from RAM, in order to make this integration function. So there's enemy health, obviously, your own health, and the number of rounds the enemy won. So first, quite strangely, the health number is 164 for this for this game. So you don't, when you search the value in RAM, you don't know that. So the way I found it is that I set, like for example, if we do a test and we search for every variable to have 0, so I let the AI beat Yokozuna. So I wait for Yokozuna health to be at 0, and then I found all the variables that was at 0. Then I restarted a round, which means that the health value increased from 0 to an unspecified number. So I narrowed down I searched for this operator here. I searched all the values that increase. It narrowed down to less possibilities. Then after I let the AI beat me and make my health reduced, so I check for all the values that decreased, and eventually you repeat this process and you get to this RAM address right here. Same thing for the RAM address in here, and same thing for the enemy health. It's the same principle. For enemy 1 rounds, it's even more simple because it starts at 0, so you search for all the values that are 0, and then you let the enemy win a round, and then you search for all the values that are at 1, like here with the is operator, and when he wins another round, you set it to 2, and that's it. You can find this specific address. So that's pretty much it for the integration. If you have any question, you can let me know down below. If you want me to integrate another game, please let me know as well. So now I tested with several models, 2 models actually. So the first, so one of the models I tested with the Impala CNN. So I made a video about the Impala CNN. I think it's the last video I made. It's about the Impala CNN, so you can check that out. So it's a neural network that can generalize a bit better than the Nature CNN. If you want more details, you can check the video about it. So I trained one for 20 million frames. This on my RTX 2060. This is about 10 hours more or less of training. So let's try it. So now I'm just playing it back. So I'll retrain. So you will see that his first opponent, Shawn Michaels, even at the hardest difficulty, he can usually beat him easily. So when he gets off the ring, he can get back up easily, normally, except for a few exceptions. So just to make it clear, the AI is Yokozuna, it's the sumo fighter. Now you see at the bottom left environment, he's already at the Razor Raymond. Usually he beats this guy easily as well. So now you can see he's against himself. So I was quite worried about this because the frame is in black and white. What is fed to the neural network is not in color; it's in black and white. So I was wondering how we can distinguish between these two fighters. But actually, he does quite well. There's not much problem with it. Now against Bret Hart, this is a harder opponent. He can beat him too. As you can see, he just had trouble getting back on the ring. He hesitated for some reason. Okay, so now this is interesting. He's against two opponents. So he was the model was able to generate quite well. So even with two opponents, he can understand that he needs to beat both instead of being just confused most of the time. But when he's off, for some reason, when he's off the ring with two opponents, he has trouble getting back up. I notice. Well, not in this case, but so he can still win a few rounds against two opponents. But that said, even after 20 million time steps of training, he can't beat the game. As you can see, he lost, and he's back against Shawn Michaels, the first opponent again. So the way I trained it is I let it run opponent after opponent until he loses, and then he restarts. This is not very effective. Like the most effective way, and I'm working on it, is to separate, have a different state file, different training session for every opponent, and training with equal time on each of them, instead of having it go through the game by himself, because in that way he overfits on the first opponents and not on the opponents that are closer to the end. He gets much less training, so that's not very effective. So I'll work on these states, and I'll submit these states as well as the two-player state. So now let's try with the CNN model. So I tried with the CNN model with only 1 million time steps. And it still works quite well. He can beat the first opponent. And probably the second. I don't remember. Let's check it out. So 1 million time steps for the CNN model on RTX 2060 Super is quite quick. You can train it easily under an hour. I think half an hour, maybe. You can train that on the laptop as well. So you see, he has beaten Shawn Michaels. He's at Razor Raymond. I think he can beat Razor Raymond. Oh, he has trouble against himself with a CNN model. So you get the idea. So he has more trouble than Impala CNN after 20 million time steps. That's obvious, but it still does quite well for the few training he had. So next step is I plan to, as I said, I plan to make model versus model, and maybe organize a tournament if people are interested. So if you have feature requests or are interested in this tournament about with a wrestling game where you have AI versus AI, where we can try different algorithms and network architecture, please let me know. You can comment in the section down below. So thanks for watching, and don't forget to press the like button and subscribe.